Hello everyone, and welcome to another Physics 210 online lab simulation walkthrough. Again, my name is Alec Lancaster, and today we're going to be having a chat about projectile motion, and we get to fire stuff out of cannons, so that's pretty exciting. Before you do any of this, please make sure, or before you watch this video, please make sure that you've read through the theory section in the attached Projectile Lab manual, and that you go and do the pre-lab that's in there as well under the computer skills section. Once you have done all of that, go ahead and navigate to the simulation for this week. I would suggest running it in Google Chrome because that's what worked for me. I'm sure the rest of the browsers out there will work, but Google Chrome always seems to be a bit superior in my opinion, so go ahead and use that if you have access to it. Finally, make sure that you have an Excel spreadsheet set up for this. I would go ahead and read through the procedure here before you really attempt this so that you can have your Excel spreadsheet ready to go and ready to collect that data. So let me go ahead and reset all of this here. So what you're going to do is you're going to go to the that website that I outlined up here. You click on the intro section, and you can see you'll have a cannon, a little stand that it goes on, I guess a marble outline of a human for scale. I don't know. And all right, so that's the setup. We're going to set the simulation to the intersection in the top right. We're going to make sure that the object that we're firing out of this is a cannonball. I guess you could use a pumpkin if you wanted to have a bit more fun, but I'm going to use a cannonball. And ensure that all of these boxes over here are left unchecked. You don't want to mess with those. Finally, in the lower left-hand corner, we're going to set the initial speed to 10 meters per second and set the initial height to 1 meter. Now, as the name of this data collection section says, horizontal projectile motion, we're not going to be adjusting the angle at which we are firing the projectile for this section of the lab. We'll get to that eventually, but for now, make sure it's set to 0 degrees and do not adjust it. Now, we're going to use initial heights of 1, 4, 8, 11, and 15 meters to fill out the spreadsheet. So make sure that you've already set that up in Excel or Google Sheets or what have you. First of all, what I want you to do, go ahead and calculate for each of those. Go ahead and calculate the horizontal distance that you believe the object is going to travel using kinematics and the equations that are in the theory section of the lab. If you're having trouble with that, of course, we can talk that over in help room hours or something like that, but I won't go through and calculate all those for you here. But once you've done all of those, go ahead and, pause the video if you haven't done it yet, and then come back and we can get going with the rest of it. So I have it set at 1 meter. I'm going to go ahead and fire the projectile. Actually, let me zoom in on things here. Going to fire it. You can see it barely traveled at all. Ostensibly, the projectile was in the back of the cannon, so that's why you see this kind of path traced out throughout the cannon as well. And next, we're going to use this tape measure. I'm going to set it at 0, which is right here. Make sure, you'll notice this tape measure actually has 2 spots on it. There's that first crosshair here and the second crosshair here. You want to line the first crosshair up with 0 and then measure the distance the ball traveled. And it looks like it traveled about 4.52 meters, so you can go ahead and mark that down. Next, we're going to raise this up to 4 meters. Oh, I clicked the wrong thing. Going to raise it up to 4 meters. And once again, I will fire the cannon. And what's nice is that you can actually see the trajectory of the previous ones that you fired as well. So once again, I'm going to set this up at 0. I'm actually just going to leave it here this time. And we're going to measure how much further it went. Okay, so it looks like it went about 9.04 meters. And next up, it says to raise it up to 8 meters. And I'm going to zoom out of the simulation a little bit. Fire it. And it looks as though we got to about 12.77 meters. Next up, we raised to about 11 meters. Fire it. And it just so happens that it landed on this target, which is movable, but we're not using that right now. All right, let's measure that horizontal distance here. It looks like 14.97. You can call it 15 meters if you want to. It's pretty much the same thing. And finally, we're going to raise it all the way up to 15 meters and fire it. And looks as though we got to about 17.43 meters there. So go ahead and fill that out in your Excel spreadsheets and go ahead and do the rest of these steps. So it asks you to determine the difference, if any, between your measurements and the actual values. There will probably be a bit of a difference between them, although hopefully your calculations are relatively close to the simulation. And then you are asked to make a table of the horizontal distance traveled versus the initial height. And in that table kind of compare the values that you calculated versus the values that you got. Okay, moving on to the second part, where we will be varying the angle at which we're firing the projectile from. We are told to set the initial height to 0 meters, that's very important, and to leave the initial velocity at 10 meters per second. Once we've done that, what I'd like you to do on your own is use kinematics and physical reasoning to determine the angle at which the maximum horizontal distance will be achieved. So, we could set it between, ostensibly here, 25 degrees and 90 degrees. So what angle, or which angle, sorry, is going to give us the maximum horizontal distance? You can imagine if you shoot it straight up, you're not going to get any horizontal distance. And if you shoot it at 25, you get some. But somewhere in between there, you're going to maximize this horizontal distance. So go ahead and use physics to calculate that, and to calculate the angle at which that will happen. And then using that angular prediction, predict the maximum horizontal distance that it's going to travel. Once you've done that, for each angle of 25, 35, 45, 65, and so on, do the following. We're going to fire the projectile and then measure the range the projectile went. So I'm going to set up my tape measure right at the origin, which is right here, and then set the cannon to 25 degrees, fire it, and we'll measure that distance. All right, so looks like we got about 7.8 meters at 25 degrees. Moving on, I'll set it to 35 degrees, fire it, take a measurement. All right, so it was about 9.6 meters, we can call that, at 35 degrees. Moving up to 45 degrees, give it a shot and measure the distance. It's about 10.18 or 10.2 meters at 45 degrees. Next, we're going to jump up to 65 degrees, and I'm actually going to clear these because it's going to get a little cluttered if I don't. All right, so we just fired, and you can see it actually went back a little bit, and looks to be about 7.78 meters at 65 degrees. And finally, we'll fire it at 85 degrees, which is almost straight up in the air. And you can see we traveled about 1.74 meters. All right, so feel free to pause the video, rewind it, or whatever to take that data again if you need, or take the data on your own. This day's lab is a little easier than the rest of them, or than the previous one at least. So go ahead and take that data, and then in your lab reports, of course, go ahead and answer these few questions that are here. Write up your conclusion and all that, and we'll be good to go. One thing that I want you to think about specifically is if you perform this experiment in real life, do you think your predictions would have been closer or further from the experimental values? And that can be a bit of a tricky thing to think about, but one hint for that would be, since we're using an online simulation and I can just turn air resistance off, right? And I can set these at exact heights and I can set the cannon to be shooting from an exact angle and all of that. Everything that I'm doing online is pretty exact. So that should match the theory really, 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 really well. If it doesn't, then the simulation could just be wrong. But I would suspect that if I myself were to do these experiments in real life, my predictions might be a little worse than they would have been, or they wouldn't have matched with the experiment as much if I had done them in person. Hope that makes a bit of sense. Again, if you have any questions, we can always meet and talk on the Blackboard or Zoom or what have you. And thanks for watching. Have a great day.